Welcome to the podcast of Data and Analytics in Business. We will learn from the leading industry experts using data and analytics to solve the problems and create values in practice. We will also learn where the industry is heading to and how data and analytics will shape the industry in the future. Most importantly, how they are preparing their business for digital transformation and disruption in the future. I'm your host, Jason Tan, and thank you for listening. In this episode, we have got Fahd Saghir. Fahd is the chairman of the Society of Petroleum Engineers, and he is also the digital solution manager at Schneider Electric. Schneider Electric is a global specialist in energy management and automation with operation in more than 100 countries. And Fahd is going to be talking with us a lot of the things about the edge analytic and also the Internet of Things, and how the Internet of Things or the edge analytic are revolutionizing the upstream oil and gas industry. One of the topics that we dwell into really deep is about the use of the edge of analytic and why edge of analytic is important, and in particular of like how it is collecting and processing the data on the side before it is sending the data to the cloud. I think this is probably the most important thing that you probably want to take away from this episode, apart from all the gold nuggets that Fahd are sharing, is why is it important just to send the right amount of the data to the cloud? Because otherwise, every data that you're sending to the cloud, it could be costing you money. On top of that, obviously, Fahd will be sharing with us various examples of how data analytic machine learning are being used to solve the business problem for the oil and gas industry. If you have any question for me or Fahd, feel free to send us a voice message through the Anchor app, and I hope you will enjoy this episode. Thank you. Hey Fahd, welcome to the Analytics Show. I'm so excited to have you on the show today, and we're going to be talking about the use of the IoT and the data analytics and the machine learning in the oil and gas industry.
Hi, Jason. Thanks for having me on your show. Glad to be here. Excited to answer some of your questions and basically take the audience on a journey on how IoT machine learning works in the oil and gas domain. So thanks for having me.
I am super excited to talk about with you all of those things. Now, from my research that I found that you are very passionate about the data intelligence in relation to the petroleum industry. Would you like to share with us what made you growing such an interest in this field?
Well, I would say mostly by accident and by chance, Jason. So I finished my bachelor's from the University of Houston. And Houston is a big oil and gas town. And as soon as I graduated, I started working for a startup that was making wireless sensors for the oil and gas industry and doing some remote monitoring for assets that you use in oil and gas applications. So that got me started in the field of oil and gas, and I never looked back. I had some excellent mentors in the industry. It was always possible for me to ask questions and get detailed answers. So that started me on the journey. And one of the good things is that I brought my electrical engineering domain into the oil and gas. And that helped me realize the value of getting data from sensors, etc. So put all of that together, and that is what makes me passionate about data intelligence in the petroleum industry and how that has changed over time and where it has landed at this point in places where you have concepts such as digital oil fields or intelligent oil fields. So that concept itself has, again, driven my passion on providing solutions to customers within the petroleum industry.
One of the things that I am always advocating is the importance of the domain expertise. What I mean by that is combining the domain expertise and the knowledge with the data and analytics will only make it more powerful because you understand the business, you understand the data and analytics. I suppose the question I have for you and something that I pick up just now is that your domain expertise in terms of the electrical engineering, it seems to be creating a really good foundation for your machine learning and the IoT device. How would you say to anyone, especially those who are coming from the electrical engineering background, say that how this is helping you to get into this data science industry or field?
Yeah, look, I believe that data science can be applied to any knowledge domain, right? And the advantage that I get from having an electrical engineering background is because I've worked a lot with the electrical hardware and software. And what that helps me doing is I can take that knowledge and I can know exactly how I need to work with the electronics to capture the data in a way that simplifies aggregation of data, that simplifies how you can take that data from a very remote site on a customer premise and send it either to a localized control center or you can send it up to the cloud. So having that knowledge, it basically helps me guide an end-to-end data pipeline that makes it easier for the customer to access data. Once you have easy access to data, then you can build models and then you can start doing things from there. Unless and until you don't have that data pipeline, it becomes difficult for you to leverage your data intelligence and whatever machine learning applications that you can build around it. So you're exactly right. Domain knowledge is very important. And as an electrical engineer, what I help my colleagues sometimes understand who have some vertical knowledge, whatnot, is how to make that data delivery simpler for the end users.
That's amazing. So what is your role of a digital solution manager at Schneider Electric entail? What are your major responsibilities?
Yeah, look, I've been with Schneider Electric for quite some time now. And so the digital solutions manager role was something that I started almost a bit over a year and a half ago. And in this role, I am responsible for taking the concepts of cloud, AI, machine learning, edge analytics, hashing them together and providing a customer a complete end-to-end experience on how they can leverage value out of their data. So as the digital solutions manager, I work with a group within Schneider Electric that is basically managing all the data model building. Then there is a group that works on the complete end-to-end data architecture. So I combine those knowledge and skill sets and try putting together a solution that will add value to customers in the petroleum and the oil and gas industry. And I would say one of my major, there are quite a bit of responsibilities, but what I would say is my major responsibility is working with customers, right? Listening to their problems, finding out what makes them lose sleep at night and how we can make sure that they run a smooth operation and give them data in a way, shape, and form that helps them accelerate their decision making. And once you do that, that is where you add value with these technologies, right? So that role with Schneider, I would say it's one of the most interesting roles I've ever had. Is it allows me to work with technology, but it also brings in the factor of working with people and then providing solution to them after getting to know their problem.
Do you mind to share with us an example, like how that is being used to help them to solve a business problem, whether it's helping them to optimize the production or whether it's helping them to reduce the cost, any sort of business case study?
Yeah, so I'll take the very first example that on a solution that we developed in Schneider Electric was an oil and gas production. Your biggest asset is the reservoir from which you're producing either oil or from which you're producing gas, right? And you have a lot of pumps or you have a lot of wells which will produce either oil or gas. And most of these wells, when they start declining in production, you put in a pumping artificial lift system. Artificial lift is where you use pump or you use some other form of recovery to extract oil and gas from the reservoir. So one of the unique problems that we solved very early on was leveraging one of the products from Schneider, which controls these pumps, and taking data from that pump and converting it into what we call an image. And usually an expert would have to look at that data. It's an XY plot. It's called a dynagraph card. If people want to look it up, basically that dynagraph card is a position versus load curve. And you can usually take it and train a machine learning model to identify the shape of that XY plot. And that will tell you if the pump is having a problem, such as gas interference or you have solids inside the pump, anything that would damage the pump, right? And what we did was we put an edge device right next to that well, collecting data from a variable speed drive, and we were able to convert that XY curve into an image and use machine vision to identify the problem by looking at that dynagraph card and then provide an output to the operator to take proper action, right? Rather than wait for someone to look at that data. What many people don't understand is in oil and gas, all these assets, pumping wells, etc., they're in remote locations. They're hundreds of kilometers away from the city, and you cannot get data in real time. So that is why you need to do something on the site itself that can enhance or improve the performance of that asset. So that was one of the early problems we solved. And with Schneider Electric, we published papers, and with our technology partners, we published papers. It was well accepted within the oil and gas industry as well. And we are doing a few projects around that technology right now.
Wow, that's amazing. I really like that example. I think the use of the data science in the oil and gas industry is probably a new thing to most of our listeners. So would you give us an overview of what kind of technology is used and how they are being used in the field apart from that example?
Yeah, so there are a lot of technologies. And one thing that I would like to point out to your audience is before, when NASA was the only company that had a supercomputer in the US, the only other industry that had a supercomputer outside that industry was oil and gas. And the reason is the very first process of the oil and gas life cycle is exploration. So exploration is where you take seismic or geographical surveys of a big mass of land and you make these 3D seismic plots. 3D now, but previously you made these seismic plots. And those seismic plots were a lot of data. And based on the seismic plots, you could tell how much oil or how much gas you had in a certain geographical area. And that would basically start your business plan. So the technology has been there. However, I would say in oil and gas, we started becoming lazy after that, right? We used technology early on, but because oil prices were at a level where everyone was comfortable, technology wasn't adapted quick enough. And then basically, I would say the adaptation of technology became a bit slow. But at the turn of the century, especially when I graduated, there was this concept about the digital oil field. Everyone wanted to get data because they realized that if you gathered real-time data, you could add more value to business and you can make decisions in as near real time as possible. So the adaptation of technology has improved dramatically. And this was around the time when I was graduating. So you started seeing things like wireless sensors. You started things as image analytics being done in the oil and gas domain, especially around what they call the upstream production areas, etc. And as we've moved along with the different fluctuations and shocks in the market with pricing, the adaptation has been there. My only comment to that would be that it has not been a common adaptation across the industry. Every company is trying to do their own thing. Some have done it better, some are still learning, and some have just started the journey.
Right. So as you are in this industry for more than 15 years, you have seen all the recent development for taking place right in front of you. Can you share with us the major progress in terms of the data technology in this oil and gas and how they have changed the energy industry then?
Yeah. So again, I go back to the time when I came out of university and I started seeing all these technologies come up. So yeah, last 15 years have been great in terms of the developments that have taken place, right? So your electronics have gotten much smarter over the time, right? Now, one thing, again, the audience needs to understand, developing an electronic board for your household application is very different for an industrial application. The reason for that is the electronics need to survive harsh conditions. They need to work in minus 40 to 70 degrees Celsius temperature. So very wide range of temperature. Those technologies have improved. The processing capabilities of those technologies have improved. How you gather data, how you process data, that has improved quite a bit. Companies have started standardizing on how they collect data, bring it to what they call their automation SCADA systems. And then from the SCADA systems, they take it to historians, and from the data historians onwards, use it in business applications. The other big development that I see is the advent of 4G, 5G technology, right? So you previously, if you had to collect data from a remote site, you had to have a remote satellite link, and that was very expensive. And with the advent of 4G, 5G technology, you can now collect data with a much higher frequency, with a much lower cost, and that changes the way you can access or you can get access to real-time data. And in the past 3 years, of course, cloud machine learning have used up a lot of buzzword space, but IoT, especially industrial IoT, I believe is going to be a game changer because it brings the best of the IT world and it brings the best of the operational technology world. And the way these are merging, there are now overlaps where these technologies can provide the best of both worlds, work in high temperature, but also do 4G, 5G communication and data management in a localized device. So I believe that philosophy and that understanding of how you manage, gather, collect data and bring it to a common platform is one of the developments I'm really excited about because that just unleashes how you can then work with the cloud AI and the ML technologies altogether. And I think that will be adapted very quickly within the energy industry. And as I said, some companies are really fast tracking their adaptation of newer technologies. Some of them are doing it one step at a time. Others are just starting and everyone knows the end goal. It's just that they're taking a different path to reach that goal.
I'm going to come back about the IoT device later. But before that, I want to ask you, I have heard of this term SCADA over and over again, and I never really looked it up myself. Do you want to explain a little bit about what is SCADA system?
So let me see if I can break it down. So SCADA stands for Supervisory, Control, and Data Acquisition. So SCADA is basically a hardware software package. So basically your high-end servers on which you're running a software that is connected to devices in the field. So even before there was IoT, companies were still gathering data from field devices, pressure, temperature, vibration, current consumption, etc., and bringing them back through small electronic devices such as RTUs, which are remote telemetry units, and programmable logic controllers, which would then connect to SCADA, right? So basically, SCADA was your go-to system for gathering data from remote sites using UHF radio, microwave links. So companies, again, if you look at some of the major oil and gas companies, how they collect data from these remote sites is they build their own wireless network, have the sensors transmit the data over the wireless network, and they store it in the SCADA system. The SCADA system not only stores data, but it also provides a graphical interface to the operator to take proper action, right? So that term SCADA is very well known in not only in the oil and gas industry, but for many industries. And SCADA, because they have built-in historians, became your de facto go-to point to collect data and do analysis on it, right? Especially from the remote assets that were connected to the SCADA system.
Right. So to some extent, can I simplify using the analogy of saying IoT device is actually the evolution of the SCADA, which become smaller, cheaper, and even can be made for anything and everywhere and everything then?
Exactly. So the combination of IoT and cloud was previously SCADA and RTUs, PLCs, and it is now transforming into cloud-based systems and IoT devices. Yep. So that analogy is pretty much in line with the growth of that system.
Now I want to come back to that, the IoT and the cloud technology that you were talking about. I suppose that is another terminology for that, and correct me if I'm wrong, but I think it is what you call the edge analytic. Is that correct? And if so, why is it important for the industrial setup, and how this edge analytic, for those people who have never really heard of it before, can you explain what it is and why it is important? I only just learned about this as I was doing the research about this interview.
Yeah, no, fair enough. Look, edge analytics, and people will define, whoever you talk to will define edge in a different way, shape, or form. Edge can be a server sitting right before you send data off to the cloud, right? For the industrial application, an edge device or an IoT device, and they're interlinked, which I will explain in a minute. But an edge device in the industrial application is a device which is sitting at the logical extreme of a customer's entire process. In oil and gas, in the petroleum industry, usually that is your well, your oil or gas well from where you're producing hydrocarbons, right? And the reason why you want to do analytics right on the logical extreme is people don't realize that getting continuous connectivity to the cloud from that asset is very difficult, because you may not have 4G, 5G coverage all the way to that asset. Even if you have it, you cannot transmit data every second to the cloud, because the amount of data that you send is correlated to the cost of data packages that you would get to communicate with the cloud as right. So the edge IoT devices, or a different way of calling them, are IIoT, Industrial Internet of Things devices. These devices are built to work in harsh conditions. They are built to basically aggregate, do data analysis right next to the asset. And once they've done the analytics, they only publish important results to the cloud, and they do not need continuous connectivity to the cloud all the time. So it's like putting a small brain right next to the asset, which is thinking for that asset and then processing, crunching numbers, and then pushing the right information to the cloud, which can help the end users take actionable insight.
Right. So is this something new, or is it something that is more of like has been evolving over the time and over the years already?
This has been evolving over the years, right? So I tell a lot of people, so Internet of Things, again, it is a big market buzzword. Back in 2006, 7, when I started working with wireless sensors, we were already sending it to quote unquote the cloud in those days, which was a server sitting in a protected control center somewhere, right? That has evolved over time, definitely has. And what has evolved is that these powerful devices, which have more processing capabilities, have more power, have now adopted to the industrial environment, which I mentioned, minus 40 to 70 degrees. And they're made to work in harsh environment where basically people do not only go when there is something important to check, right? So it has involved the industrial Internet of Things. Again, although it is a buzzword, that evolution started way back. And we've reached a point where we're now seeing maturity in those solutions. And that hardware platform, that entire solution platform, now allows us to do edge analytics.
So from the business perspective, and perhaps I am trying to take the listener and myself to go through that visualization, that from the business perspective, how is the edge analytic is solving the problem from your customer then? And is it something that could perhaps be applicable outside of the oil and gas industry that you may have seen?
Yeah, right. Look, you're exactly right. So what we are doing here is the value that we give a customer, right? So imagine you have 6,000 oil producing wells scattered over 1,000 square kilometer, right? That is the amount of geography and the scale at which these wells are spread over huge areas. And you usually have one operator to look after, let's say, 200 or 250 of these wells. It is not humanly possible for that person to look at the entire 250 wells in a single day. What we're doing with edge analytics is we are processing the data on the edge. Either you have cloud connectivity, you don't have cloud connectivity. And basically what happens is when we run those analytics on the edge and we take a decision with the mathematics or with the number crunching that's running inside that IIoT device, we can then inform the end user, especially their operations and maintenance teams, to focus on wells which require attention and not to worry about everything else and anything else. So we are giving those operators more time to look at important tasks and not look at things which are not going to bother them over, let's say, next week or things of that nature, right? And that is where edge analytics becomes a game changer for a lot of our customers in the oil and gas industry, where you have a machine learning algorithm. And the example I used earlier, where they use a Dynagraph card to tell you the shape of what that pump is going through. And if you do that in real time, it will tell the operator where to spend their most time and not waste their time on other things, right? So that's adding value. That's putting time back into the customer's pocket. And time is value, time is money. Now, that solution easily transcends into other verticals. Since I've started working with these solutions about 2 years ago, this has transcended into mining. It has transcended into water, wastewater. It has transcended into food and beverage problems. So everyone has a common problem. Every industry is trying to optimize. They're trying to improve. And if I can put time back into their daily schedule and let them take care of important tasks and tell them what needs to be optimized, what is the process that can actually put money back in their pocket, I will do that, right? And again, the solutions that of what I'm learning, and this is very recent in the last 6 months, not only applies to oil and gas, it can apply to other verticals as well.
So I suppose from the costing perspective and from the overall strategy, in order to apply this solution to other vertical, I think other vertical or other industry, like for example, the manufacturing, they may not necessarily share the problem of the oil and gas where sending the data to the cloud at a super remote site is a problem. But from the costing perspective, the edge analytic would be able to process all the data and aggregate the important numbers and the result and send it to the cloud rather than sending every single data that is collected within that and to the cloud. As you were saying, because it is a costing as well, sending every single data. That could be another way of looking at how and why they should be considering the edge analytic as the middle step before sending the data to the cloud.
And you mentioned it exactly correctly, Jason. So the very first thing that we try doing as companies that provide technology solutions is to reduce not only the cost impact, which we call the capital expense, CAPEX for short, but we also try adding value where it makes most sense, right? And I used a term early on called accelerated decision making. The process itself of sending data to the cloud and doing streaming analytics in a manufacturing plant, which you correctly mentioned, is very different to oil and gas. I would rather have an operator working in that manufacturing plant, working with technology that gives them a result which they can action immediately, right? On a cloud application that may not be feasible. I'm not saying it's impossible, but in a manufacturing plant, you cannot be connected to the internet all the time, right? If the customer has a SCADA system, I might rather have an IIoT technology that interfaces with the existing operational technology and provide value right then and there. And one of the industries that I would like to mention where I've seen this being adapted very quickly is water, wastewater. Here in Australia, for example, I've been talking to a lot of customers who have now started seeing value of putting these IIoT devices and just sending the correct information to the cloud so they don't overwhelm their operation. They don't overwhelm their maintenance team and just report what is necessary, right? Too much of data can be a cause of headache and too little data can be a cause of headache. So we're trying to find the right balance. So again, the technology can be adapted in multiple verticals. Oil and gas has its unique challenges. It has a lot of remote sites. So if you try solving the most extreme problems, you can then take that and apply to other verticals and the solution becomes adaptable.
That's really amazing. I was really extremely interesting because that's something that I have never learned before. So apart from this edge analytic, what are the new tech solutions you are working on?
Well, one of the things, actually, we try putting everything together with the edge analytics itself. So machine vision on the edge has become a big hot topic recently. So basically, you have your CCTV cameras, right? In the industrial space, CCTV cameras do very different tasks to what you would do, let's say, if you're going to a shopping center, etc., right? In the industrial domain, CCTV cameras, you looked at problems. For example, if you use thermal imaging camera, there's technology available in the market, which if you point it towards the pipeline, it can tell you if there is gas leaking from the pipeline or if there is some hydrocarbon leaks, right? So use it for safety systems. But recently, and again, CCTV cameras and remote sites have the same problem. You cannot keep sending 720 frames per second back to the cloud in near real time. So how do you use that data to interface with the existing infrastructure, do analytics on the edge, and then provide the operator or the maintenance team or the end user with the right insight? So one of the examples that I'll use on machine vision is basically, and again, this is very recent as well, on a mining site where you have rocks going on a conveyor belt, you can put a CCTV camera pointing towards that conveyor belt and looking at the size of the rocks in real time and giving feedback to the operator if they need to do something different with the crushing activity of the plant, etc. So you are now using things such as object detection. You are now seeing things as velocity of objects to decide how you improve your analysis. And again, this is not in a plant, this is in remote sites, right? Plants have been using CCTV cameras because they're indoor, but on remote assets, this becomes even a better challenge, even a better problem to solve. So that's one. And the second technology, which is up and coming in this, is the augmented reality, is where you send a maintenance crew out to site. And basically, if you have an asset within your iPad programmed and you just point your iPad towards that asset, it tells the operator on how to solve a certain issue. So that, I believe, will be the 2 points which will dramatically pick up, given the world we are living in, the problems we are facing right now, the challenges we have. I think those are the two things which the IIoT concept will adapt very quickly, and they will become a de facto solution for all customers, not just in oil and gas, but in other verticals as well.
Imagine like how you connect that whole visual recognition with the CCTV in recognizing the size of the rock, and then have you got it connected to the machine, and then it automatically do the crushing. It will be crazy then.
I know. So a lot of steps, and actually you raise a good point. One of the things that we've seen is with artificial intelligence, machine learning, there is a concept known as closed loop control, where you allow the machine to take an action rather than a human taking an action. So what we try to do is we introduce this concept of augmented intelligence. Augmented intelligence is where human expertise help adapt the machine learning, artificial intelligence process, right? So you put the human in the loop, you put the subject matter expert in the loop, and they can then take action based on the output from these technologies and not only improve the process, but also help build better machine learning, accurate machine learning models. So that is one part of this technology which I would really like to highlight, is things like augmented intelligence, where you capture a feedback from an actual person and make it part of the artificial intelligence workflow.
I think that's one thing that I want to highlight in there, is that the role of the human play in this whole loop and in this whole solution in terms of teaching the machine to learn, especially in the super early stage of the solution. I think a lot of people, especially the general public, would have this misconception that the machine learning out of the thin air automatically know how to do all those things by itself. The reality, it is not. We still need to teach the machine, and the role that human play in the super early stage is super important. And I'm glad that you highlight that.
No, I agree. And again, these technologies complement what we as humans try to do, right? And I look at them as enablers. Nothing's going to take over the world and start controlling things automatically, right? Because the most important part in those two words, machine learning, is the part of learning, right? And the best way to teach a machine to take an action, or a best way to work with a machine, is to provide human feedback into that loop and then improve the efficiency and improve the outcomes, especially in industrial domains where optimizing business, optimizing processes is a very important KPI for our end users, for our customers.
I'm curious to know, from my research, is what is artificial lift in oil and gas, and how process automation is being used in this area about the artificial lift?
Right. So I think I touched upon this a bit earlier. So imagine you drill a well, an oil well, thousands of feet subsurface. And you might have seen this in the Hollywood movies, that the oil starts gushing out from the ground and everyone's happy because they're going to make a lot of money. Well, it's not that simple anymore, because over a period of time, what happens is these oil and gas reservoirs, which are 8,000 feet below the ground, they lose their natural pressure. So when they lose their natural pressure, they lose their ability to push that fluid from 8,000 feet below the ground all the way to the surface. So what you do is you try using methodologies where you put a pump 8,000 feet below the ground to extract that oil out of the reservoir. So it's actually putting a pump thousands of feet below the ground to improve the extraction of oil, and that is called artificial lift. So lifting the oil out of the reservoir by using pumps, by using gas injection or methods which are methods which are basically allowing you to extract more oil out of that reserve is known as artificial lift. So I've given a very generic terminology. I can explain it in more complicated terms, but for the audience, the simple term is using either a pump or any other secondary method to extract oil where the reservoir is losing or has lost its natural pressure.
Now, let's get a view of your life as a researcher. Please share with us about the valuable research that you are doing right now for the energy industry and machine learning.
Yeah, well, that makes me lose sleep in the night, right? So, my research is I'm not going to say very unique. I would say I'm very lucky that I'm getting to do research in a subject that I'm passionate about. So I'm doing my PhD in petroleum engineering. So even though I'm an electrical engineer, I decided to take this path of doing my research in petroleum engineering. But my topic is applying machine learning to artificial lift method that is commonly used in Queensland for the coal seam gas operations that we have specifically in Queensland. And part of my research is to use historical data and to build an application which identifies in real time if you're going to have a problem with that artificial lift method. I'm not focusing on actually predicting failure. My focus in that research is how you can define a life of that pump, for example, or that asset, and how you can use that information to historically improve the process in the long run. So optimization through performance enhancement. One of the benefits that I saw that came out of that research was when I looked at data, one of the unique things that I did was I took what is known as time series data, something that you would see in the stock markets, where you see the stock price changing, whatnot. So I took the problem of time series data and I converted it into a problem of machine vision. And I'm not going to take a lot of time here. So basically, my research is looking at converting time series data into images. And because machine learning algorithms are so good at recognizing shapes in an image, I can then take those images and classify how the pump or how that artificial lift method is performing, and hence allow the operator to take any corrective action or help surveillance engineers better understand the performance of their pump over time. So again, my research has made me lose sleep at night, etc., but I enjoy it nonetheless. And to me, it's bringing together the best of both worlds, what I do as an electrical engineer and what I try doing in terms of getting subject matter expertise in the domain of petroleum engineering.
Now, talking about the future, how would you evaluate the digital transformation of the energy industry so far? And how much more development can we expect in the near future?
Yeah, if you asked me this question in January, I would have been giving you a very different answer. But because we are in the era of COVID-19, I am seeing the adaptation accelerate dramatically in the energy industry of such technologies. So I'm talking to end users, customers in mining, in oil and gas, in water, wastewater. I have not seen the digital projects slow down. I've seen them speed up, right? I've seen some amazing requirements that these companies are now requesting technology companies like Schneider Electric to bring forward and talk to them about and help them realize their digital transformation journey, that I believe that the adaptation has become much easier, or it will become easier with what we are seeing with the remote work and etc. And the adaptation level will be much better. So I think I mentioned earlier, everyone knows what the end goal is, and all customers, companies are taking a different path. Now, everyone knows what the end goal is, and now they have a catalyst in COVID-19 to help them fast track their journey, right? And as I said, some customers will have an easy journey, some of them will have a difficult journey, but nonetheless, everyone is ready to transform and see how such technologies like artificial intelligence, machine learning are not just buzzwords, but you can actually use them in day-to-day operations and help you basically move from those manual processes to automating tasks, which can help you operate in a safer, in a much better way.
That brings me to my final two questions. So the first one is that I always ask my guests is, what is your most important first principle?
So my most important first principle is trust. And the reason why I say trust is because I've worked in the industry, and one of the things that I've learned over my 15 years of experience, if you do not establish trust, no matter how good a technology or how good a solution you have, it makes no point, right? So if you're able to establish a level of trust, not just with your peers, your colleagues, your family, but as an overall expert in some technology, that is what makes. So if I go and talk to someone and the person, let's say, trusts what I'm trying to tell them, and they know that I have, and I'm not trying to just use marketing, and I'm not just trying to use examples which have never happened, but actually show them live demonstrations of how technology performs, and hence establishing trust. Once you have trust, the rest of the journey becomes very easy. So I think that is one of the most important first principles that I use is around establishing trust, no matter who you're dealing with in your day-to-day life. Once you have trust, rest of the conversations become easy.
What is one book that you have read and thought it would have been better for your younger self to have?
So many books, right? But yeah, look, I take my time reading books, right? I don't go through pages of books. I take my time, I try absorbing. So one of the books that I read a couple of years ago was a book called Outliers by Malcolm Gladwell. It's a book on psychology, and it was released in 2008. And I wish I would have read it when it was released. It talks about, basically the topic is outliers, things which are out of the normal. So things like success, etc. And he talks about various personalities on how they achieve success. But the underlying point in his book was that journey, that community around success is different for each and every person, right? And the underlying factors might be common across the board for people in different domains, but the way you get to success is unique to all of these. So the underlying factor of success is unique to each and every individual, right? And I really love that book. The opening chapter of that book, and I'm not going to reveal much for the users. I would recommend they go read this book. But the opening chapter is just phenomenal, and it sets a good tone for the rest of the chapters in the book.
Wonderful. I sure will check that book out, and also have it listed on the blog article so that people can check it out. Now, Fahd, thank you so much for sharing with us all of these knowledge, especially with the age analytic, and going into the details of how it can be used for different vertical, and also the whole thinking behind that, the role that it plays before the data get into the cloud. I think I must admit that before I talked to you, I wasn't actually thinking about why it should be doing in that way. But now I have a really clear picture, but also equally, now we have a really good idea about how machine learning and data and analytics can be used in the oil and gas. And I really, really enjoyed this conversation and interview. I'm sure that the listener will equally enjoy it. Thank you so much.
Thank you, Jason. Pleasure talking to you.